In this video, we're going to continue our examination of the two-way chi-square and step through the actual calculations. And this is pertinent to a 2 by 2 chi-square analysis. The first step in our research question of whether there is a relationship between personality type and the presence of cardiovascular disease is that we compute what are called expected frequencies, and these are separate from observed frequencies. And just to define a few items here, uppercase N, and you'll see this on the table below shortly, refers to the total of all frequencies. Essentially, this is our overall sample size. FE is the expected frequency, and you'll see the equation of that here shortly. The expected frequency is related to the probability that a participant falling into a cell if the two variables are independent. And so recall that what we are evaluating if there's a dependency between the two variables in our study. And the equation to calculate the expected frequency, and this is the expected frequency that we would do for each of the 4 cells in this type of research design, is we would take the cell's row total, so this is the total across the entire row, multiply that by the cell's column total of the observed frequencies, and divide it by n, the overall sample size. And so we see that here. So coming back to our data that we saw on slide number 16, our observed number of type A with cardiovascular disease is 25, type B is 10. With no cardiovascular disease, once again you see that there are considerably more people without cardiovascular disease of type B personalities as compared to type A. So to carry out the expected frequency is we would take the 35, which is the total along the row, multiply it by the column total, which is 30, and divide it by the overall sample size, the uppercase N, which is 80, and then we have a value of 13.13, which is the expected frequency. And so if you take a look through this table, you'll see how we execute this equation, where we multiply the 35 by the 50, once again divided by 80, 45 multiplied by 30 for this cell here, and 45 times 50 divided by 80 for this lower right-hand cell. And so once we have those data, the F observed, the observed frequency, and the expected frequency separately for each of these 4 cells, we can then calculate our test statistic, which is our chi-square value. And this is the observed chi-square from the data. And the equation, as you can see here, is we take the difference between the observed frequency and the expected frequency in each cell separately. We square it to eliminate the positive or negative, so that way all the data will be positive values, and we multiply it by that cell's expected frequency. So this is done for one cell, then we repeat it for another cell, and the 4th cell, and we add up all of those numbers, keeping in line with our symbol of summation. In terms of the degrees of freedom, the degrees of freedom is simply the number of rows, subtract 1, times the number of columns, subtract 1. And since this is a 2 by 2 design, our degrees of freedom here will just be a value of 1. So if our data is statistically significant, we would conclude that there is a dependency or a correlation of having cardiovascular disease and personality type, and then we would take a look at the data and interpret those data relative to this conclusion. So let's complete our calculation of our observed chi-square values. So we take our equation, I just copied the top equation, put it down here at the bottom, and we fill in the data. So in our first cell, we take the difference between the observed frequency and the expected. This value is squared, divided by the expected, and we would add that to the next cell, which along the first row, which is 10 subtract 21.88. We square that difference to eliminate the negative value, divided by 21.88, and we continue. We move down into the second row, and that first cell in the second row is a 5 subtract 16.88. Likewise, in the right-hand cell in the second row is a 40 minus 21.13 squared, and we divide it by 28.13, and then we add up all those data, and we get our test statistic of 30.56. So once we have that calculated, once again, just to reiterate what I had indicated on slide 18, our degrees of freedom is a 2 rows subtract 1, which is 1, times 2 columns subtract 1, which is 1. So our degrees of freedom in this case is going to be 1. And now we find the critical value in the chi-square table given a degree of freedom of 1, and unless stated otherwise, we routinely go with the alpha level of 0.05. And what we will find is that our chi-square calculated will exceed the chi-square critical value. So our calculated chi-square is actually quite a large number, and the critical value of 3.84 is that value that is our threshold or cutoff between the 0.05 level and higher probabilities of committing a type 1 error. So we've made the decision to go with 0.05. And because our chi-squared calculated exceeds our critical value, we reject the null hypothesis, and by rejecting the null hypothesis, we then pivot to the alternative and conclude that the frequency of participants assigned to one category of one factor is dependent on the categorization on the other factor. And so we go back to our original data, and just subjectively, we observed that there were more participants that had cardiovascular disease and were classified as a type A personality, while more participants without cardiovascular disease were classified as type B. Now we can state that there is based upon this sample, a statistically significant relationship in that a personality type is related to the probability of having cardiovascular disease or not. Another way to describe the two-way relationship for the chi-square is to calculate correlation coefficients that accompany the analysis, and this will bring a little bit more clarity to the what's often referred to as the effect size or the strength of this relationship, because the previous analysis does not overtly tell us if it's a strong relationship or if it's a weak type of relationship. And so what we would do at this point is we would calculate what's called the phi coefficient, and this is a coefficient that ranges between 0 and positive 1. So this calculation will not yield a negative correlation value. It's still interpreted as a correlation value, but it will only range between 0 and 1. And this, in terms of interpreting this calculation, we would essentially compare our calculation to an ideal situation where a phi value of 0 is a zero correlation, and that's where the two variables, personality type and presence of cardiovascular disease, are completely independent of each other. One does not predict the other. The other ideal is if the phi coefficient is exactly 1, where they're perfectly dependent. And when we deal with real data, we're going to have something in between. And to calculate the phi coefficient, we would use this equation where we take our chi-square value from our previous analysis on slide 19 and divide it by the sample size, and we take the square root, where n is the total number of participants that we would put in the denominator under the square root symbol. Once we've calculated this value, the phi coefficient, that gives us a description of the strength of that relationship. If we square that value, the squared value is interpreted as the percent accuracy in being able to predict one variable from the other. And so this is analogous to the coefficient of determination with a regular regression analysis where the R-squared value is interpreted as a percent variability accounted for by the independent variable. And so what we see here in stepping through our calculations, if we take our chi-square value of 30.56, we divide it by our sample size, and we have a correlation phi coefficient of 0.62. And we would classify this as a moderate strength correlation. If we take the square of this value, we just take the 0.62 and multiply it by itself, we would find a value of 0.38. And we would interpret this as a percent if we move the decimal place over to the right twice. So by multiplying this value by 100%, we would conclude that we are 38% more accurate in predicting cardiovascular disease if we know a person's personality type. Now, we look at this and say, well, 38% is not a very large proportion in terms of predicting cardiovascular disease, but what this reveals is the proportion that can be predicted from personality type. The balance with 100% would be accounted for by other factors that were not part of this study. So there are a number of unknown variables that were not part of this study that we would consider in predicting whether a person has cardiovascular disease or not. Now, in the event that you have a research design that is greater than 2 by 2, so if you still have two independent variables, but those independent variables have more than two levels, then such as a 2 by 3 or a 3 by 3, then you would instead of calculating the phi coefficient, you would calculate the contingency coefficient, which is very similar, but you would just take your chi-square value that you would have calculated on slides 18 and 19 and divide that by the sample size plus that chi-square value. So there's a correction made for the increased number of levels in this case. And then once that quantity is computed, you take the square root of that. And that's interpreted in the same way that you would interpret the phi coefficient squared value as we had here on slide number 21. And so generally, how you would report chi-square results for this type of design or even a simpler design is you would report the chi-square value, indicate the p-value if it is statistically significant or not if it achieves that level, and the degrees of freedom that is determined from your design. So as we looked at 2 by 2, the degrees of freedom was 1, and you would indicate the sample size. So you would write in here n equals 80. And then there is some variability in how different researchers would convey the data. You could do that in a table, or you could make bar graphs to indicate what those frequencies are across the different categories. So this ends this video on calculating the two-way chi-square.